Hi, I'm Dan Singer. I'm an associate professor of philosophy at the University of Pennsylvania, and I'm here to talk to you today about my group's chapter for the Routledge Handbook of Political Epistemology entitled Epistemic Networks and Polarization. So as I mentioned just a second ago, this is a product of the Computational Social Philosophy Lab. The Computational Social Philosophy Lab is an interdisciplinary group of researchers that looks at questions in social epistemology, philosophy of science, political epistemology. And what makes us a group is that we tend to use agent-based computer models to look at a lot of these different questions. So recently we've been primarily focused on modeling group deliberation and looking at how polarization can arise in groups and looking at the roles of diversity and expertise in groups and deliberating groups. So this chapter for the Routledge Handbook on Political Epistemology is a nice accessible example of the kind of work that the group works on. So what's the chapter about? As readers of this book probably know, U.S. politics and politics all over the world is extremely polarized, and we're probably getting more polarized. As Ezra Klein recently said, polarization is the single most important fact about American politics. And according to the Pew Research Center, polarization is dividing American society, not just politics. So what kind of phenomenon is polarization, and political polarization in particular? Well, polarization is a social phenomenon. Polarization is a complex phenomenon. And polarization is a phenomenon that can plausibly be understood, or at least generated by, interacting elements of the phenomenon itself, namely people. So what this means is that polarization is a prime candidate for study with agent-based models. Agent-based models contrast with the standard kind of aggregative model you might be familiar with from an economics class, in that in agent-based models we use simple parts and simple interactions between the parts to try to generate and explain complex emergent phenomena. So typically these models involve an element of simulation. So unlike models that you might have seen in your typical economics class where you represent them purely by equations and understand them by manipulating the equations, typically agent-based models are implemented in computer simulation, and we can look to see what happens. Another standard element of agent-based models is that they often involve stochastic processes, decisions, or interactions, that is, things that happen with a certain probability. By including these elements of the model, we can have more realistic models, but we can also have models that don't take a stand on how a certain thing goes, to let the model show us how different interactions might be produced. Epistemic network models are what philosophers of science and social epistemologists have generally used to look at social epistemic phenomena and phenomena that philosophers of science are interested in. So an epistemic network model is a kind of agent-based model. So probably the easiest way to understand what an epistemic network model is to look at an example. So let's look at an example of a rumor moving through a group of friends. So imagine Sally wants to start a rumor, and so here's Sally and the friend group that she's part of. On the graph here, we see Sally on the left. She's the black node, and the black node here is the node that has the rumor. The white nodes don't have the rumor. So Sally tells the one person she talks to at recess, and then the network looks like this. And then that one person tells the person in the center of the network, and that person in the center of the network likes to tell everybody everything, so then the information spreads to the entire group. So that's a really simple example of an epistemic network model. We can use much more complex examples of epistemic network models, though, to try to understand complex phenomena that we're interested in, like social polarization. So here we see the running of one of my group's models of polarization, and in the center red box there, you can see the group becoming polarized. So here's what we do in the chapter. In section 1, we introduce epistemic network modeling as a kind of agent-based modeling, and we contrast the epistemic network approach to thinking about political epistemology with more general aggregative approaches. In section 2, we introduce a well-known result in philosophy of science from Kevin Zollman that shows us how network structure can affect how information moves on that network. In section 3, we begin to look at polarization in particular, and we start there with potentially simple models of polarization. So there we ask whether or not it's easy to model polarization starting with a divided network. Turns out it's not as easy to do as you might think. We also look at a model from Hegzelman and Krauss from 2002 that does produce polarization using a kind of divided network. In the last section, we introduced two more recent ways of modeling polarization that don't start out with divided networks. So those two models are one from my group, from Phil Studies from a couple years ago, and an even more recent model from Kaylin O'Connor and Jim Weatherall that is still forthcoming, I think. The chapter concludes by briefly discussing some ways the framework can contribute to future work in political epistemology and work on polarization. We hope you enjoyed the chapter, and we hope it gives you some new ways of thinking about polarization and political epistemology questions using the epistemic network approach. Bye-bye.